Okay, students, we're back here on the flow chart. I want to mention something. At this point, what we have done is using the thiacetamide at acidic pH, we have separated the copper 2 from the iron 3 ions by precipitating copper 2 ions in the form of copper 2 sulfide. Now, just because you have a precipitate doesn't mean that you can claim that that particular cation is in there. And so once we've achieved the separation, which we did, separating the silver from the copper 2 from the iron 3 ions, now what we had to do is we had to do some confirmation reactions. And so the next stage, we're going to show you how to confirm for the presence of copper 2 ions and how to confirm for the presence of your iron 3 ions. So again, for the Chem 1B students, notice that we just added the thiacetamide to separate the iron 3 ions from the copper 2 sulfide precipitate. In our next step, we're going to analyze that to confirm for the presence of copper 2 ions. And later on, we're going to confirm for the presence of the iron 3 ions. Now, left behind was this silver chloride here. Now, we basically followed the solubility rules, and we know that it should be silver chloride. But it'd be interesting to see, can we confirm that? So what I do sometimes is I'm going to add a little step here. I'm going to have us take that precipitate of silver chloride, resuspend it in water. Remember, resuspend is just basically crushing the pellet into small particles. It's not soluble yet. And then we're going to add 6 molar ammonia and see what happens. Okay, remember that in our first step, we had precipitated silver chloride and we had a pellet that we washed with water just to get rid of any residual iron and iron 3 and copper 2 ions. So this should be essentially silver chloride. So what I'm going to do is I'm going to resuspend it. I'm going to bring in my distilled water bottle. I'm going to add some water in there. And once more, I'm going to use one of these little mini stir rods, and I'm going to stir it and kind of mix it up a bit. Again, remember, when you do this, all you're doing is a physical change. You are just causing the pellet to separate into very smaller particles. This is not dissolving, okay? This is called suspending the precipitate. I just want to make sure that it's all into smaller particles, okay? I'm going to take my stir rod out and put it with the other used glassware in a container that we have for that. And now what I'm going to do is I'm going to bring in my ammonia. But remember, in solution, ammonia becomes ammonium hydroxide. So let me open this. Again, hold the coin stopper top with your fingers. And I'm going to bring some of this. And I'm going to add about 15 drops of this into my solution. All right. Now I'm going to mix it. I'm going to add some more because I forgot that what I had was a suspension already. So I'm going to add a few more drops here. Remember, this is not quantitative, it's just qualitative. So we're going to see what happens. I'm going to stir it some more, and then I'm going to put it away and see what happens, okay? Okay, students, remember we had a mix from our first step, which contained a silver chloride precipitate. I resuspended it and added 6 molar ammonia. And here is what you get as a result. You have the pellet has dissolved. And later on in the semester, we'll learn why this is. The reason is that silver ions form what's called a complex ion with ammonia that makes it more soluble in solution. And so what it does is it displaces the silver ions from the silver chloride precipitate. and puts it back into solution in the form of a silver ammonia complex. Okay, we're still in the fume hood here because we still have some sulfides in the atmosphere here. And we have our pellet of copper 2 sulfide in here. But as we explained a little while ago, we need to confirm for it. So what we're going to do is I'm going to take some nitric acid. Again, I brought it into the fume hood also. Once more, dislodge the coin stopper cap. Pull it out between your fingers and get some samples here. And let's put a few drops of this in here, 15 to 20 drops into our pellet. And then what I want to do is, okay, let's put this back in there and get it out of the way. The nitric acid is going to help redissolve the pellet of copper 2 sulfide. So what I'm going to do is I'm going to bring a stir rod. I'm going to break it up and make sure I get the one on the sides. And what I'm going to do is I'm going to bring again a clothespin, and I'm going to bring it into the boiling water bath again. So let me slide over here to the side. Oops, just a moment. Let's slide over here, and here is my boiling water. And what I'm going to do is I'm going to be keeping it in there and stirring it. Let me hold it with this hand while I stir. Turn it around a little bit while I stir it for a little bit. As you can see, there's already a change in coloring. These are different colors that are going to be going through here. You're going to see it start turning like into a little yellowish, then maybe a greenish. The yellow might be a little bit of leftover iron, but most of this should start. So I'm not going to let it sit there for a few more minutes, and let's see what happens. Let me spin this around so you can see what's going on. You can see that it's starting to develop like a greenish to aqua blue kind of color as it dissolves. So let's leave it there for about 3 minutes, and let's see what happens. Okay, after 3 minutes, we want to take a look at what we have in here, and what we observe is that there's still a bit of residual precipitate. Ideally, all of it should have dissolved, but what's important here is the color of the solution. Notice the kind of like bluish greenish kind of color. That indicates the presence of copper 2 ions. That residue there could be sulfide or something. So what I'm going to do is I'm going to respin this so I can get rid of that little piece of junk in there. And I'm going to pour or decant the supernatant into a clean test tube. Okay, here is my supernatant. So I had that copper 2 sulfide pellet that I redissolved in nitric acid and heated. But after a while, there was still some solid residue. So I spun it and I decanted it into a fresh tube. And you see the aqua blue, kind of greenish kind of color that indicates the presence of copper 2 ions. But to confirm it, we're going to use another test, which is we're going to add ammonia. And similar to silver, copper 2 ions also form a complex with ammonia. But let's see what we observe here. All right. So here is, again, my ammonia. Remember, in aqueous solution, it's ammonium hydroxide. And I'm going to add it drop-wise because I want to make sure that I get the full effect here. So here is my test tube. And I'm going to add 1 drop first. I'm going to mix it. Nothing happens. Another few drops. And nothing happens. Now, you might start getting concerned and say, well, isn't this supposed to be something happening here right away? Well, here's the thing. You have to make sure that you have added sufficient ammonia. So one thing to do is to test the acidity of this. So what I'm going to do is I'm going to bring back another little piece of litmus paper, and I'm going to take my sample and I want to test it. And as you can see, actually, let me do another dab here so you can see the whole effect. As you can see, the litmus paper is getting wet, but it's not changing color. That means that my sample is still not basic enough, doesn't have enough ammonia in it. So I'm going to keep adding drops until I get it to work. So here we go. There's more ammonia. And then mix it. And you can see something happening already, right? You can see something happening already. Then it goes away. Let's add some more drops. There you go. It is forming a dark blue solution now. Let's add a little more just to get the full effect. A few more. There you go. You can see the, see against the white background, you can see the blue color there. And also what might happen is after a while you might have a competition between the formation of copper 2 hydroxide, because remember, ammonia is basic, so it produces hydroxide ions. So you have a competition between the blue color of the copper 2 ammonia complex and the formation of copper 2 hydroxide. So that is your confirmation for the presence of copper 2 ions in the original mixture. Okay, students, I'm back in the fume hood. I have my pellet that should have my iron 3 sulfide precipitate. And what I'm going to do now is I'm going to redissolve it in nitric acid. This is dilute or 6 molar nitric acid. And again, as before, it does the same thing I did with the copper one. We're going to redissolve our iron pellet. I'm going to add 15 drops of this. So that should be 15 drops. Let's put that back in there, cover our thing. And now once more, I'm going to bring a stir rod and I'm going to mix this. I'm going to get it back into solution. And once more, we're going to help ourselves by heating it in boiling water. So I'm going to bring my clothespin again, put it in here, come over here, back to our boiling water bath, which at this point is not boiling so much. But remember, the idea here is to have it very hot. It's not like you need to have it bubbling all the time. It should be close enough. So we're going to let it sit there for about 5 minutes just to make sure that the heat and the nitric acid do their work in redissolving the pellet. And every now and then, give it a little stir. Make sure you break up those clumps. When this is over, there may be some residual precipitate. Again, like I said, sulfur itself might be formed in these reactions, and so you might end up with some residual solids that we're going to remove by centrifuging our test tube. So we'll be back in 5 minutes. Okay, the 5 minutes are up, and as you can see, all of our iron 3 sulfide black precipitate has dissolved. If you still have some residual solids at this stage, what you might want to do is respin this. And you don't have to decant. You can test the supernatant of that directly. But mine has totally dissolved. And you see the yellowish color. Sometimes, iron 3 will reduce to iron 2. And somewhere in there, you get a yellowish color. So I'm going to take this back to my bench. And we're going to do the final test to confirm the presence of iron 3 ions. Okay, students, I'm back on the bench here. This is my redissolved iron sulfide precipitate. It is now iron ions in solution. And once more, we're going to take advantage of a chemical property that many of these transition metal cations have, which is the ability to form complex ions of interesting properties. In this case, we're going to use potassium thiocyanate, and we will see this reaction in other labs. But essentially, all I'm going to do is I'm going to throw in about 3 drops of this. And as you can see, we have the formation of a very deep red colored solution. That is your confirmation for the presence of iron thiocyanate. In other words, the presence of iron 3 ions in your original mixture.